Hello everybody, and let's go ahead and get started with the electromagnetic spectrum today. We're going to talk about what they are, but first of all, remember that the difference between mechanical waves and electromagnetic waves are that mechanical require a medium, electromagnetic waves do not require a medium. Okay, so that's the main difference between them. Electromagnetic waves are made by vibrating electric charges. Okay, and these electromagnetic waves are composed of changing electrical fields and magnetic fields, which is how it got its name. So magnetic fields and electric fields are what, them changing is what makes up electromagnetic waves. Now, mechanical waves transfer energy from particle to particle. And we talked about that. that they need particles as stepping stones to transfer their energy or to keep moving, right? But electromagnetic waves transfer energy between the electric and magnetic fields, which allows them to travel without matter. So they can actually travel in outer space where mechanical waves cannot. Oh, and then I've already gotten ahead of myself. So that's just saying that electromagnetic waves do not require matter to travel, because electric and magnetic fields can exist where matter is not present. So electric fields and magnetic fields do not need particles to exist or atoms to exist. And therefore, they do not require a medium. And so now let's look at the electromagnetic spectrum. Okay, this is an example of some things that are on the electromagnetic spectrum. So let's start over here on the left where my pointer is. We've got gamma rays, X-rays, ultraviolet rays, and then visible light is just right here, but it's spread out to show you the spectrum of visible light. And we have violet on the left-hand side and then red on the right-hand side. And I actually typed in the colors for you since my notes are in black and white. I typed in the colors for you so that you'd know where each color was. So, and then we have infrared after visible light, infrared, radio waves, and it should make sense. Infrared is next to the red part of the visible light spectrum. Ultraviolet is next to the violet part of the electromagnetic spectrum. Okay, so let's talk about. I want to look at this transverse wave up here. Electromagnetic waves are transverse, as you can see up here in the very top of our picture, and we are increasing energy going left to right. Okay, increasing energy going left to right. So what do you also see that's increasing going, I'm totally talking backwards. I apologize. We are increasing energy going right to left. I apologize. So increasing energy going right to left. And what else is also increasing going right to left? Frequency. Down here, they have a lot higher frequency than they do on the right-hand side. Remember, frequency is how many times a wavelength passes in 1 second. So more wavelengths are passing down here in 1 second than on the right-hand side. So as we increase energy, we also increase frequency. Now look at the size of the wavelength. The size of the wavelength, and it actually tells you right here, is increasing left to right. So down here on this side, large wavelength. On the left-hand side, small wavelength. So as energy increases, our frequency increases and our wavelength decreases. Okay? So energy and frequency, they have a relationship where they change in the same direction. Directly proportional is what we call it. So energy and frequency have a direct proportional relationship. When one increases, the other increases. They move the same direction. Energy slash frequency, they have a indirectly proportional relationship with wavelength. That means when one of them increases, wavelength decreases. When one of them decreases, wavelength increases. So the opposite change happens for wavelength in respect to energy and frequency. Okay, so down here on our visible light, violet, highest frequency. Red, lowest frequency. Okay, you need to know that. And you need to know that gamma is our highest frequency, or the type of electromagnetic wave with the most energy. Radio waves, smallest amount of energy, smallest amount of frequency, and largest wavelength. Okay, you need to be able to read the spectrum that way. Oh, and you know what? I'm going to show you guys a little demonstration. I'm going to show you guys when, first of all, we've got amplitude. So I'm going to put it back down to the middle. And I want to show you. So right now we have wavelengths, and I want to show you what happens as I increase the frequency of those wavelengths. When I increase frequency, those wavelengths become smaller. Okay, the wavelengths are closer together when I have a frequency, a higher frequency. When I lower my frequency, the wavelengths are a lot longer. They're a lot further apart from one another. And so as I increase frequency, I decrease wavelength, but energy is increased. Okay, do you see that? They're moving faster when the frequency is higher, so they have more energy, but the wavelengths are smaller. When we have less energy, my frequency is lower, and my wavelengths are larger. They're further apart. Okay, well, let's go back and finish our notes. So properties, and this is what we just talked about, but I want to make sure we get it written down. As energy increases on the electromagnetic spectrum, frequency also increases, but wavelength decreases. And the opposite is true. As energy decreases, frequency decreases, and wavelength increases. Okay, so you have to be able to read the spectrum. Let me give you an example. I want to go back to the spectrum. If I asked you, by looking at this, if it didn't have the increasing energy, increasing wavelength lines, if I said, which one has the highest frequency, X-rays or ultraviolet? You should be able to tell me that X-rays has the higher frequency, higher energy, and smaller wavelength than ultraviolet. Those are the type of questions I need you to be able to answer from the electromagnetic spectrum. Okay, so now let's summarize our video. And this is what I'd like you to do. I would like you to draw the transverse wave of the electromagnetic spectrum, and I want you to label these things where there's high energy, high frequency, and low wavelength. And then I want you to label the side that has low energy, low frequency, and large wavelength. So draw, when I say draw, I mean just draw this part right here, this transverse wave, and then tell me which side has low energy, low frequency, large wavelength, and which side has high energy, high frequency, and small wavelength. Okay? I hope you guys have a great evening, and I'll see you in class.